Good morning everyone, I am Snitter and today I'm going to replace this god-awful sky background. I also got a comment on the player texture. Somebody didn't like him, can you believe that? So I think I'll just remove the player texture and replace it with a red texture. And for the sky, I'm not going to make a new cloud texture. I'm actually going to program a shader and show you how to do that. So I'm going to start by just closing this, and I have made a little setup here. I'm going to show you what that looks like. So my setup is basically just covering the entire screen with one primitive, and I have a variable that goes from 0, 0 up here to 1, 1 down there. And I'm going to use this to create individual cells. The way I'm going to make a cloud texture or a cloud shader is by using what's called Worley noise, which is a very suited kind of noise for cloud texture because it looks a little bubbly. So I will start by creating individual cells, and I will just show you what the Worley noise looks like before I actually implement it into the game. So I have to figure out which cell the current pixel is in. Let's see. So now I have the cell index here, and if I do this, let's see. You can see that I have divided all the pixels on the screen into 10 by 10 cells. And now I want to find the distance between the current pixel and the central position of the cell. D equals distance from position to the cell position. And let's use that. Okay, so now I have this pattern, but it doesn't look good. So what I want to do instead is to randomly move each point inside the cell and see what happens then. So I have this very useful function. I have a cheat sheet on the side here. Let's see. So this is a random 2 function, which means it takes in a 2D vector and outputs a 2D vector. So if I do this, and for the seed, I will give it the cell index. So now all the points are randomly distributed around their cell, but you can see all these seams, and that's the next thing that needs to be fixed. So for any pixel inside this cell, I also want to check all the surrounding cells. So that is going to be a for loop. So instead of just checking the current cell, I will check all the surrounding cells. So that will be for float xx equal to -1. So I will loop from -1 to +1, including +1, and do the same for the y-axis. And then I'll remove this and put it in there instead. Float t equals 1. So I will set the distance to 1 to begin with, and then I will get the minimum. And for the cell, I will add a vec2, x, x, y, y. And let's see what happens now. Okay, it's starting to look like something. This is kind of resembling a Voronoi pattern, where you can see the edges between each cell. What I'm interested in is the black part here. So what if I do, if I make a new variable called density, and I do 1 minus d, And let's just do this and see what that looks like. Okay, so now it kind of looks like bubbles. And what I like to do is to just square the distance, and then you get a very fluffy kind of noise. What I also like to do is to increase the distance of which each point can be offset, just to make more dark areas and brighter centers. So I will multiply this by 2. However, now we get a new problem: more seams. So instead of looping from -1 to +1, I will loop from -2 to +2. Yes. So I'll put all of this into its own function. So that still works. Now, what I want to do is to layer multiple layers of this. So let's make a new layer. I'll call this layer 1, and then I'll make a new layer 2, and I want this to be twice or half as big, so I'll multiply the position by 2. Let's just draw layer 2 and see what that looks like. Okay, so it's the same kind of noise, but it's just smaller. What if I add these two together? And I want layer 1 to be affecting the density more than layer 2. So I will do layer 1 times 2 plus layer 2. And so let's say that this is multiplied by 1. Then I have to divide by 2 plus 1, which is 3. Let's see, I need to also put that there. Okay. And let's do one more layer. I'll multiply this by 3. Let's say 4, 2, and layer 3 times 1. 4 plus 2 is 6, plus 1 is 7. So let's divide by 7. Okay, it's starting to look like something. But I want to have more control over how much clouds are visible, so I will add another argument to this called sparsity. Let's see. I want to square that as well. Okay, so let's make a new variable here. Let's see what that looks like. And I want to control that with a uniform. And I want to control this with a mouse. So mouse Y over room height multiplied by 5. Let's see what that looks like. That was one parenthesis too many. But I don't want to do this here. I want to return density, and for the then I want to do that here. Let's see. Okay, this is starting to look like something. So I'll put all of this into its own function, and I'll call that float cloud density. And I can do this in a loop, so I'll make a new variable called float iterations. Actually, I'll int iterations 4. There we go. And for each iteration, I would like p to double. And I also need a float weight. And I want the weight to halve. Let's see, and in the end I want to divide by the sum of weights. And let's see if it still works. Nope. Sparsity, yes. By the way, I don't need that here. Also, I got an error. Oh, wait. Let's see what it looks like now. That does not look good. Why does it only do one iteration? Let's see. I add get Worley times weight. P times equals 2, okay. I don't know why that worked. There we go. So this is the cloud pattern that I'm going to use to create my cloud shader. So I'm just gonna, or there's one more thing I'd like to do. Let's reduce the number of iterations to 2. Now I think the seams between each bubble is a little too visible. Like, if you can imagine the distance graph, it goes down and then there's an abrupt change and then it goes back up. So I want to change that a little, and then we have this glorious function called smooth minimum, or smin. So I'm going to use this to smoothen out the curve a little bit. Let's see. So instead of doing the minimum, I will do the smooth minimum, and I will just play around and see what smoothing coefficient is best. Okay, I can work with this. Let's try 0.2 and see what that looks like. And let's increase the iterations to 3. Point 15. Yeah, I'll go with that. Okay, so I'm going to copy all of this into the... I'm just going to find the YouTube video here. Okay, so here's the YouTube video for the Gravity Platformer Part 3, and this is the previous video. And I will download the source from here so that you can follow as well if you'd like. So let's just boot this up into GameMaker. And save it as part 4. There we go. Okay, so I'm drawing the clouds in the draw event down here. So the clouds are using its own special shader called SH Sky. So I will just edit the shader today, so I can just full screen this. Let's increase the text size. Sorry about not doing that earlier, but now it's done. Okay, so the position of each vertex is actually stored in the normal. So I will use this. Let's just see how much I can salvage from the other shader. I'll rename or recast this to a vec3. And that can just be equal to the normal. And when drawing, let's just use this directly. And see what happens. Vec4. So now we have a 3D coordinate for each pixel on the sky background, and we can work with that. So I will just copy over all the functions that I just made, get Worley and cloud density, and instead of the random2 function, I have another one called random3. I also need the smooth minimum function. There we go. And I'll copy over the main function as well. So I need to change all the vec2s to vec3. So that should be a vec3. And in the get Worley function, it's pretty much the same, except I'm going to do 3 loops. One for X, one for Y, and one for Z. Let's see if it works now. I forgot the sparsity. Let's just name this, let's set it to 2.1 and see what happens. Okay, it's a little sparse, and I think they're a little too small, so let's increase the position. Actually, let's reduce the factor there. Okay, this is something we can work with. So this is 3 iterations. Let's see what 4 iterations looks like. Yes. So for the cloud or the sky background, let's make that. So I'll create a new color, vec4. Let's do a vec3 actually. Just put this up there. Vec3, sky color, and I want this to be some kind of blue color, so a low red, slightly more green, and a high blue color. And let's do cloud color as well. This can just be 0.5. And let's mix between the sky color and the cloud color using the density, almost wrote dentistry. And let's see what that looks like. That is absolutely terrible. Okay, so now we have some clouds, but they don't look very good. They look pretty terrible, actually. So the next thing I'm going to do is to simulate light shining onto the clouds. I figured this explanation might make more sense with a graphic. Imagine the sky as a thin sphere around the player. The clouds are in a sense 2D in that they only consist of the slice this sphere makes through the Worley noise. However, clouds without lighting look flat and dull, so I'd like to use lighting to simulate volume. So let's add a sun up above and analyze how this will affect the clouds that are drawn. The cloud at the opposite side of the sun will receive the most light at the side pointing towards the sun. We can simulate this by making it brighter depending on the density of the cloud itself, resulting in a bright center and dark edges. As for the clouds that are to the side of the player, we want these to look like they're lit from above. This can be done by doing another density check at the direction the light is coming from. The less dense the area above the cloud, the more it should be lit. And last, the clouds that are placed between the player and the sun should have their edges lit up, while the densest part will let no light shine through. These three effects combined will create some nice looking clouds. So I want to define a light vector, light direction. So this will point in the direction the sunlight is traveling. So the sun will be placed at the other end, so I can actually place that as well. For now, let's use 1, 1, 0, 0, minus 1. So there are, I want the clouds to look kind of 3D, even though they are 2D in the sense that they are stuck to the surface of the sphere. So they aren't really volumetric, but I can simulate volume by shining a light onto them. So there are multiple ways of doing this. I will shine onto normal, and this is the same kind of lighting that is usually done for vertex lighting. Let's see, so cloud color is that. So I will again use the light dot product, and when this is positive I want the clouds to be brighter, so let's add something to the cloud color, and that should be light dp times vec 3.5. So now they should be white in the direction pointing away from the let's see, from the sun, and they should be gray when pointing towards the sun. So this is away from the sun, I guess, and this is towards the sun. But I also want to multiply the density with this. So now the denser areas are more lit up. Also, I think the borders of the clouds, they fizzle out a little too quickly, so let's change the function here by doing a minimum. Actually, I could do a small smooth minimum, but let's do a minimum first. So I have I want the density of the cloud to increase very quickly towards something close to 1 and then just smoothen off and slowly go up to 1. So I'll set this to 0.6 plus 0.4 times density. And let's see what it looks like now. Okay, still doesn't look good, but I mean, it's something to work with. So this is the cloud that's pointing away from the sun, and this is pointing towards it. And yeah, notice how this is even darker than 0.5. So I need to change this a bit. So instead of going from -1 to 1, I wanted to go from 0 to 1. So let us add 1 to this times 0.5. And now, so now the clouds pointing away from the sun are lit up. Okay. Now I want these clouds that are perpendicular to the sun. I want to light up the side of the cloud. And the way I'm going to do that is to basically do another check slightly towards the sun and see what the density is there. So let's do a shine onto cloud onto top of cloud, let's call it that. Now let's check the density at the position, and let's subtract the light direction times 0.1. And then I can do this, cloud color plus equals density check. And remove that and see what that looks like. Alright, I need to subtract that, and I need to do 1 minus that. Because the denser it is, the darker it should be, and the less dense it is, the brighter it should be. Okay, it's starting to look like something, but I want this to taper off more quickly, and it's a little too bright, so let's reduce it slightly. So now as light is shining down onto the cloud. Yeah, and you can play with the values for this for eternity. The next thing I will do, and I will probably turn off the camera just to prepare a little bit, but the Worley noise process that I'm doing here is very, very slow. Notice how it's going from -2 to +2. That is 5 iterations for this, times 5 for this, that's 25, times 5 for this, that's 125 random calls, and smooth minimums, and floors, and vec3s. So that is a lot of calculation. In addition, it's performed 4 times here, and it's done twice here, so that's 4 times 2 times 125, that's a lot of iterations. Luckily, you can put all of this into its own texture. And that is the next thing I'm going to do. Basically just pre-calculate the texture and use that to draw the clouds. So I am going to play around with the values a little bit, make it look good, and I'll be right back. Actually, there's one thing I'd like to show before I cut off, and that is that you can make the clouds move. So what I want to do then is to pass the to change the cell position and this value here. I will actually remove that, and I will create a new vector, vec3 rand vector, a random 3 cell. Then I want to offset this. I'll do each dimension individually. So I want to do a rand vec times .x times the sign and let's define pi because that's not defined by default. 3.14159, and I'll add the random vector .z times time. So let's just do current time over 100 and see what that looks like. And let's do this for all the other dimensions as well, y and z. And since this is just 3 random values, I'll use the reuse them just to save some time. Let's see what this looks like. I need to add there, and also I would like some info about the scale, so let's just give it a scale there. So the smaller the clouds, the larger this should be. And let's just give it 1 over weight for now and see what that looks like. So yeah. Now the pattern is randomly generated each step. Okay, so after playing around with the values a little bit, this is what I ended up at. Now the shader is pretty slow, so to be able to use it, I will have to bake the texture. But I will upload it as it is, and it can't really be used as it is, but you can look at the code. It's easier to understand what it looks like right now. Also, there is one thing I forgot to do, and I will do that right now. Let's remove the player sprite. So let's replace it with something else. Let's make it blue, and I want the front to be a let's see what that looks like. I want to see be able to see which direction the player is facing. So hopefully that is slightly better. So I've been working a little off camera, and I want to show you just how this system performs. So this is the non-baked version. I'm gonna set the game set speed just to get like a pointer for how fast the game is running. And in the draw GUI I have draw text FPS, and let's see what FPS I'm getting with the non-baked version of the shader. So now with the game speed unlimited, I'm getting like 40 FPS, and this is a GTX 1070 card, so it's a pretty heavy shader. But I've been playing around and trying to figure out how to bake this. Let's see. So what I'm doing in the new system is to create a surface that I've named Baked Worley Surface. And on this I create a 3D texture, and that means that I mean this. Let's see, I want to show the texture before I show anything else. So let's remove the, okay. So now I'm drawing the 3D texture onto screen, and let's just set the blend mode. Is it one word? GPU set blend mode. Next, PM1, PM0, and let's try that. Okay, so what you're looking at here is the 3D texture that I'm using. So basically, the entire volume is split up into layers. So there are 8 by 8 layers, and there are 1024 divided by 8 pixels in each square. So let's see how this actually performs. I will remove this and I will draw the FPS again, and let's unlimit the game set speed. And let's see what that looks like. So that is considerably faster than the previous version. Now it's running at 3500 FPS. Let's remove that again, and I think I'm only doing a few iterations. Let's do 5 iterations. That's a little too much. Let's do 4. Okay, so these are some pretty nice looking clouds. And let's just make sure that it's still running at high speeds. 3.4 thousand. So the problem, or it's not really a problem, but the change is that you can't have the same kind of randomness as you can have when you generate the noise directly in the shader. So like I'm doing here, if you remember, the clouds moved around randomly. That is not possible here, but when it comes to the surface, I have 4 values: red, green, blue, and alpha, and I'm using them to the max. So I'm storing the Worley noise of the current pixel in the red channel, and then I'm storing the Worley noise of the pixel 1 layer above in the z-axis, so that I can interpolate between them smoothly in the z direction as well. So interpolation in the x and y direction is done by just enabling texture filtering. Let's see, so this line here enables that, but the interpolation in the z direction needs to be done manually, so I'm doing that here. So this function called Worley accepts a 3D vector, and it will turn that vector into UV coordinates onto that texture that you just saw, and it will get a color, and this color contains all the info I need about the current layer and the layer above it. But I also have the blue and alpha channels, so I use that to store a completely different Worley noise. So I just add 0.5. So it's only offset by 0.5, but that's enough to create some kind of random pattern. So if we change the flow of time here, you can see that we do have some variation. So the clouds are moving slightly, even though they're just moving back and forth. And that concludes my tutorial about clouds. If you have any questions, feel free to ask in the comment section. This has been a very fun experience. Sorry about not showing the entire process with creating the 3D texture, but the code will, as always, be available in the description, so you can have a look at it and see if any of it makes sense to you. So, thank you for joining me for this video, and I'll see you around for the next one.